Let's go to page 641. This is lesson 13-7. And the objective of this lesson is to use formulas for sine and cosine of a sum or difference. So let's say if you're looking for the value of sine of 75 degrees. Now if you're allowed to use calculator, you can just punch in the numbers and you get a number. However, this number is not exact because there were a whole bunch of decimal digits and you have to chop it off. Okay, so oftentimes you have to find exact answers. And so what you need to do is you need to break this the 75 degrees into the spatial angles like 30, 45, and 60, or like 90. Okay, so you break it down, and then after that you have to use the addition or subtraction formula. Okay, for the sine and cosine. So here the sum formula for sine, and here's a difference formula for sine, the sum for cosine, difference for cosine. So these are the formula you're going to use to simplify that. Okay, so let's go over how can we use this to evaluate that to get an exact answer. Okay, so let's go to page 641 and example 1a. So you're looking for sine of 75 degrees. Okay, now from geometry, you know about the 30, 60, 90 spatial triangle. You know the 45, 45, 90 spatial triangle, but there's no 75. So what you need to do is you need to break this number into two angles that you're familiar with. Okay, so this is equal to sine of, so whenever you see the 5, one of the number would be a 45. Okay, so 45 plus 30. Okay, so 45 plus 30 will give you 75. Okay, so now you know both angles because those are from your spatial triangles. The next thing you have to do is you use your sum. Okay, so you have to use this formula over here. So the sine of first plus second will equal to sine first, cosine second. Okay, so and so forth. So again, what you want to do is you need to go and write, sine of in a book they use alpha and beta. Okay, so this is equal to sine alpha cosine beta plus, I kind of, it depends on how you memorize it. They kind of switch the term, but I like to keep the sign in the front. I like to switch the alphabets. Okay, I kind of, this is the way I memorize it. Okay, so sine of 45 degrees plus 30 degrees. Okay, this will equal to sine of 45 degrees cosine of 30 degrees plus sine of 30 degrees cosine of 45 degrees. Okay, and then from here again you can evaluate, remember, from your triangle. So 45 triangle, this would be 1, and this would be square root of 2 over 2, square root of 2 over 2, right? Now for the 30 degrees, this would be 1/2, and this would be square root of 3 over 2. Okay, so these are the spatial triangle you need to know because the trigonometry is based on the spatial triangle, so you got to know that. Okay, so evaluate, so sine is this one over here, so it would be square root of 2 over 2. Cosine of 30, so you have to look at each triangle, cosine would be this over that. Okay, sine of 30, so it would be 1/2. Cosine of 45 would be this over there, so it would be square root of 2 over 2. Okay, and then you just go and simplify, so you got square root of 6 over 4 plus square root of 2 over 4. And if you put them all together into one term, this would be square root of 6 plus square root of 2 over 4. Okay. Now example 1b, you're looking for cosine of 195 degrees. Again, you want to break down into two numbers that you're familiar with. You can use any angle as long as they're equal to 195. So again, when you see the 5, right away, there's going to be a 45. So I'm going to use 45, and then so 195 minus 45 will give you 150. Okay. Now in a book, the book they use 240 minus 45. Again, doesn't matter as long as you can use any combination to get 195. Okay, and so this one again, use your identity. So this one cosine, this is sum. So you have to use this one over here. Okay, and so you go to that. So you just use the formula. So this equal to cosine of 45 degrees, cosine of 150 degrees minus sine of 45 degrees, sine of 150 degrees. Okay, so now you have to draw two triangles, one for the 45, one for the 150. Okay, so 45 would be over here again, square root of 2 over 2, square root of 2 over 2. This is for the 45 degrees. Now the 150 is going to be right over here. Okay, so this would, so 150, the theta is 150, so your alpha is 30. Okay, so this be 1/2 square root of 3 over 2. So first get a length, then you have to get a correct sign. So this is negative. Okay, so now you have to substitute. So cosine of 45, you have to use this one here. So it be square root of 2 over 2. Cosine of 150 is this one here. So it be negative square root of 3 over 2 minus sine of 45 is this one here. Sine of 150 is this one here. So you have to know how to evaluate. And so this will equal to negative square root of 6 over 4 minus square root of 2 over 4. And if you factor out a negative 1, so it would be negative square root of 6 plus square root of 2 over 4. Okay. Okay, let's go to example 2 to prove. Okay, you want to prove identity, so you got cosine of 3 pi over 2 minus theta. This is equal to negative sine theta. Okay, so this is the difference, so you want to use the cosine identity. So you have to use this, the difference, this one here. Okay, so this will equal to, okay, so you want to prove, so you want to keep one side the same. So this would become cosine of 3 pi over 2 cosine of theta, and this would become plus sine of 3 over 2 and sine of theta. Okay, so use the identity and then you evaluate. So the 3 pi over 2 is right over here. Okay, so cosine is horizontal, so this is equal to 0. The sine over here, this is equal to negative 1. And so this is also, you're going to get negative sine theta equal to negative sine theta. Okay, and put a check mark.